the life expectancy of a certain bacteria represented by the probability density function. Determine the probability of the bacteria living for more than 10 days. Use mathematical reasoning to justify your response. Okay, so first thing, I'm just going to do a little sketch so I can think about this. Now, it's not going to look like the normal distribution. Maybe it could, but it probably doesn't. Look, he's a funny colour. He's a funny colour. He's a funny little thing. Let's make it like that. Okay, not normal. There we go. Determine the probability of bacteria living for more than 10 days. So there's the 10. If we want it to be more than 10, it's anything up this way. Whee! Okay, which means that that's all the way up to infinity. Use mathematical reasoning to justify your response. All right, pretty simple. Let's go. So all we're going to do, integrate p of x between our boundaries of 10 all the way up to infinity with respect to x, and we're going to see what we get. So integrate from 10 to infinity. Our function is 1 over x squared with respect to x. Now, that's like saying x to the power of -2. So when I integrate that, I'm adding 1 there, and it'll be all over whatever this power is. So we're going to be left with 1 over x to the power negative. So that'll be -1 or minus 1 over x. And we've got infinity, 10. Okay, so next thing I'm going to do is just substitute those values in. 1 over, or minus, sorry, negative 1 over infinity, minus, now this is where your negatives will come in, minus the negative 1 over 10. Okay, which will change this into a plus. Now, this is the part where we have to state something to use our mathematical reasoning, and it's what happens as our limit for this approaches 0. So if I put in the number 1 here, it would be 1. If I put in 0.1, it's going to get less. If I put in 0.00001, you'll see that this is approaching as we get to larger, Look, as we get to larger numbers down there, or the closer we get to positive infinity, this whole thing is going to get closer to 0. So, limit as x approaches infinity is equal to 0, which means that this whole term gets knocked out, and I'm left with 1 over 10 or 0.1. Okay, so from here, all I'm going to state is that our probability that our random variable is little one eats the big one all the way up to Nope, that's the wrong way around. Correct that. Okay, so it's larger than 10. Are we including 10? Living for more than 10 days, so we're not including him, is equal to 0.1.